Hello students, today I am discussing redox reactions by ion-electron method in acidic medium. It is a very easy topic and in first year it is a 4 marks question. Most people fear about this question because it has some, I am recording a video because its proceeding method is very difficult. So most students are feared about to attempt this question. But don't fear about this question because it is a easy method. If you understand properly, it will be very easy to write in your examination. 4 out of 4 marks will be awarded for this question. First of all, if you want to attempt these type of questions in IP examination, first you must have to know something about these reactions. That means it is a balancing redox reaction by ion-electron method. Why we are saying ion-electron method? Because there are two methods for the solving of balancing redox reaction. One is oxidation method and another one is ion-electron method. But in IP point of view, ion-electron method is the most common method. It is the only method which is given in IP exam point of view. And another more important, in ion-electron method also there are two mediums. One is acidic medium and another one is basic medium. But don't feared about this question, which type of medium it will give. Mostly in previous 10 years IP exam point of view papers, mostly acidic medium is given by in IP exam point of view. First, suppose if you want to write question about this topic, you have to aware which type of medium it will give. Remember, suppose if these type of questions appeared in exam point of view, they will compulsorily mention the medium. Suppose here it is acidic medium. In some situations, if the medium is not present in a written form of the question, they will give on arrow mark. Suppose just like H plus. H plus means acidic medium. So first you have to aware of which type of medium we have to use to write this question. In some cases it will be written in question, or in some cases it will be written on arrow mark, or in some cases it will be written in the back side besides of the question. That means reaction acidic medium. Okay, so we know that this question, this redox balancing redox reaction, we have to solve this question in acidic medium. So we confirm that. The first step for solving redox reaction, we have to find out the oxidation reaction and reduction reaction. Actually, what is the meaning of redox reaction? The chemical reaction in which both oxidation and reduction can be happened simultaneously. So then the reactions are called as a redox reaction. So that means if it is a redox reaction, in this reaction we have oxidation reaction and another one is a redox reaction. We have to find out the which one is oxidation reaction, which one is reduction reaction. I will give you two methods for finding the oxidation reaction and redox reaction the given question in the given question. How? First one, let me find out the oxidation numbers of main important atoms in the reaction. For example, here Mn we have to find the oxidation number. Here S we have to find the oxidation number. For Mn2 plus we have to find the oxidation number, and S we have to find the oxidation number. Let us deal. Suppose if you want to find out the oxidation number of MnO4 minus, let me solve. The which one we have to find the oxidation number? Let it be X plus. How many oxygens are here? 4 oxygens are here. So 4 into, normally the general oxidation number of oxygen is minus 2. That is equal to, we have to equalize the this type of oxidations, suppose if it is a neutral molecule, we will write equal to 0, but here it is a ion, so we have to write the ion charge, that means -1. So x plus 2 into 4 minus 8, that is equal to -1. Let us get the -8 that side, so that is equal to -1 plus 8, that is equal to x plus 7. So oxidation number of here M is plus 7. Next, here let us write, let it be x as a, let it be s as a x plus 3, common oxidation state of oxygen is -2, and we have to equalize that equation to -2. So x plus x, -6 is equal to -2. So send that -6 that side, -2 plus 6, that is equal to x plus 4. So oxidation number of S here is plus 4. Here let us find out. Here we don't have to find the oxidation number because it is a single atom and it is a ion. So in these cases oxidation number will be the charge of the atom. So here the charge of atom is plus 2, and here also x plus 4 into -2, that is equal to -2, x minus 8, that is equal to -2. Suppose let it be -8 goes to that side, -2 plus 8, x is equal to plus 6. So 1 minute. Sorry for the disturbance. Let us see. So we are finding oxidation numbers. Why we are finding oxidation numbers of this every atom, every molecule of a balanced redox reaction? Because suppose let us see from MnO4 minus 2, Mn2 plus. Here see plus 7 plus 2, that means oxidation number is decreased. So decrease oxidation number, we will call it as reduction. Increasing oxidation number, we will call it as oxidation. Okay, so by find out oxidation numbers of each species in the balancing redox reaction, we will confirm where redox reaction happen, where oxidation reaction is happen. So it is the first method. This is the method is mainly used for balancing, find outing oxidation number. It is very utilized for the find out reduction reaction and oxidation number. But it is a too long time process, because in examination we cannot have that much of time to return this question. So I will tell you the easy method how to find out. Suppose let us see. According to the definitions of oxidation and reductions, we will know increasing oxygens is called as oxidation, decreasing oxygens is called as reduction. Let us see. Here For Mn, 4 oxygens are attached. For here, no oxygens are attached. That means from here to here, decreasing oxygens are happen. So that's why it is called as a reduction. Here, S is attached to 3 oxygen, S is attached to 4 oxygens. That means here to here, oxidation reaction is happening. Is it okay? It is very simple method, na? Because finding oxidation numbers of each species in balancing redox reaction, and we have to calculate increasing oxidation number, decreasing oxidation number. It is a little bit difficult. But here, increasing oxidation, increasing oxygens, number of oxygen, decreasing oxygens, it is very easy method. So, if you want to find out the oxidation reactions and reduction reactions in a balanced redox reactions, you can use both oxidation methods and this type of method. But in my view, it is very easy method because we can simply find out the oxidation reaction and reduction reaction. So, in first step of balancing redox reaction by ion electron method in acidic medium, we have to find out the which half of reaction is reduction reaction, which half reaction is oxidation reaction. So, now what we do? Let us divide the paper. Let us divide the paper in two halves. Right, one side write oxidation and another type write reduction. Okay, one side write oxidation and another type another side write reduction. So, what is the oxidation reaction here? SO2, sorry, SO3 2 minus gives rise to SO4 2 minus. SO3 2 minus gives rise to SO4 2 minus. And here in this side, MnO4 minus gives rise to Mn2 plus. Okay. So this is half oxidation half reaction and this is reduction half reaction. So let us start the procedure. The first step we have to move. What is that? Balancing other atoms then oxygen and hydrogen. What is the meaning of this sentence? Meaning of this sentence is we have to balance the other atoms which are present in oxidation half reaction, reduction half reaction. How? Let us see. Here number of oxygens are 1. Number of sulfur atoms are 1, and this side also number of sulfur atoms are 1. So it is a balanced condition, no problem it is. Even though some students are writing this equation in IP exam point of view, here already is balanced, so we don't write this step, but it is not correct, students, because even though it is a balanced condition, you have to return this step in exam point of view. So here SO3 2 minus gives rise to SO4 2 minus, and here also MnO4 minus gives rise to Mn2 plus. Next, so first step is completed, and let us write second step. In second step, we have to balancing oxygen atoms by using water molecules. So in second step, we have to balance the oxygen atoms this side and the other side. So let us see. Here S is attached to 3 oxygen atoms. Here S is attached to 4 oxygen atoms. That means here 1 oxygen atom is lefted. So we have to balance a number of oxygen atoms by using water molecules. So we know 1 water molecule contains 1 oxygen atom. So we need 1 water molecule here. So we have to, that means we have to add 1 water molecule this side. So SO3 2 minus plus 1 water molecule gives rise to SO4 2 minus. Okay. Let us see. Here Mn is attached to 4 oxygen atoms. Here Mn is not attached to any oxygen atom. That means here number of oxygen atoms are lefted. So we have to add 4 water molecules in this side because 4 water molecules contains 4 oxygen atoms. So MnO4 minus gives rise to Mn2 plus plus 4H2O. So here this side and that side oxygen atoms are balanced. Okay, next third step. Let us see third step. What is third step? Balancing hydrogen atoms by using H plus ions. It's very important. See, in acidic medium, suppose we want to balance hydrogen atoms, we have to use H plus ions. So let us see. Here, this side, there are 2 hydrogen atoms. This side, no hydrogen atoms are present. So we have to balance hydrogens this side and that side. So we have to add 2 hydrogen atoms, this 2 H plus ions this side. So SO3 2 minus plus H2O gives rise to SO4 2 minus plus 2H plus. Okay, here there are 8 H2, 8 hydrogens. 4 into 2, 8 hydrogen atoms are here. Here there is no hydrogen atom. So we have how many hydrogen ions are we have to use here? 8 H plus ions we have to add this side. So MnO4 minus plus 8 H plus gives rise to Mn2 plus plus 4H2O. Okay, students. So third step is also completed, and the fourth step, it's very important step. In IP point of view, students also will write these 3 steps very fastly because it is very easy to write. But in fourth step, it is very difficult because in fourth step we have to balance charges. Charge by using electrons. It is very important. Here most people follow many types of methods for balancing charges, but here I will tell you very easy method. Just go through it. What is that? I will do a small calculation in this part. If it in that calculation, if you get positive value, then you have to add electrons at that side and that amount of electrons. If you get negative value in these calculations, you have to add the electrons in opposite side. That means if you get positive value, you have to add the electrons in that side. If you get negative value, you have to add electrons in opposite side. Let us see. Just see. Here, charge of SO3 2 minus is -2. Every neutral molecule have 0 charge, and here also -2, and here also one hydrogen atom having +1. There are 2 hydrogen atom, that means +2. Okay, let us just remember this. So -2 plus 2, so gets cancelled and it will become 0. Here -2 0, so value is -2. So in this calculation we get -2 value. So that means we have to add 2 electrons in opposite side. We have to use 2 electrons, add 2 electrons in opposite side. So it is okay. So here let us calculate. -1 charge is, and one hydrogen atom having +1. That means here 8 hydrogen atoms are there, hydrogen ions are there. So it will +8. Here Mn2 plus, here 0. Let us see, -1 plus 8. So it will be plus 7. So here plus 2 plus 7. Both side is same charges. So just cancel. That means here the value is plus 5. Just remove that value plus 5. So here you know positive value is appeared. So that means you have to add 5 electrons this side. So let us see the step. SO3 2 minus plus H2O gives rise to SO4 2 minus plus 2H plus. How many electrons we have to add it? 2 electrons. So 2E. And this side also the step will be MnO4 minus plus 8H plus 5 electrons gives rise to Mn2 plus 4H2. Okay, so just calculate the charges. It will be the easy step. Don't go through other methods. Some of the persons following oxidation numbers and many methods are there, but I think calculating charges, it will be very helpful in your IP exam point. And final step, fifth step. Actually the fifth step is not needed in all cases. In a few cases it will be needed, because in final balancing redox reaction we have to write the net balancing reaction without electrons. For that's why we have to do fifth step. That means suppose here we have 5 electrons, here we have 2 electrons. Suppose we want to write net balanced reactions, we have to cancel these electrons and these electrons. How we can cancel the electrons? This is 5 electrons, this is 2 electrons. How we can cancel? By multiplying with suitable number. Suppose let us multiply this equation 5. Suppose if you write 5, multiply with 5 this equation, so then the equation will be 5SO3 2 minus plus 5H2O and gives rise to 5 SO4 2 minus plus 10H plus, and the electrons will be 10. And multiply this equation with 2 MnO4 plus 16H plus 10 electrons gives rise to 2Mn2 plus H2O. So these final 5 steps are completed, but one more step is also there. We have to write that one more step just like this. I don't have much space here, so I am writing the next step in this area. So here all balancing steps are completed, and we have to write the final net balanced equation. How we will write the net balanced reaction? Let us take this reaction by one. That means 5 SO3 2 minus plus 5 H2O gives rise to 5 SO4 2 minus plus 10 H plus 10 E. And let us write this equation. 2 MnO4 minus plus 16 H plus gives rise to 10 electrons gives rise to 2 Mn2 plus 8 H2O. Just remember one important point here. In the fourth step, you are balancing charges both sides. If you do calculations correctly, then you can get electrons. Suppose here you get electrons this side. If you do calculation correctly, then in this side you get electrons opposite side. Here you get electrons this side, here you get electrons this side. That means you are doing your calculation is correctly in perfect way. Suppose if you do calculations in wrong way, you can get electrons both in same side. Suppose here electrons are there, here electrons are there. So same side electrons are present. So that means you are doing calculation, you did calculations wrongly. So here let us see. Cancel 10 electrons, 10 electrons. Just write what are the remaining species are here. Most people are think another more step here also. What is that means? They cancelled H plus, this side H plus, water molecules they will cancel. If you can do that type of calculation you can, but it is no need. We have to write the balancing redox reaction without electrons. So just I am writing SO3. Suppose if you want to cancel hydrogens or water molecules, then let us do 16H plus 10H plus. So that means 6H plus are remains. So here 5H2O, 8H2O, 3 water molecules are remain. So let us see 5 SO3 2 minus plus 2 MnO4 minus plus 6 H plus, and then gives rise to 5SO4 2 minus plus 2 Mn2 plus, and there are remaining 3 water molecules, and this is the final net balanced reaction. So students, balancing redox reaction by ion electron method in acidic medium is very easy method, but if you try some more examples it will be very easy to you. So these are the five steps, important steps for proceeding the balancing redox reactions in acidic medium. So final net balanced reaction we have to write without removing electrons this side and that side. So this is the method. If you have any doubts, please contact me. Thank you.